So the new topic we'll start today, that is electricity. And in this one, in this topic, you will learn about the electrical quantities as well as the electrical circuits and how different components are used in electrical circuit. So the basic physical quantity, which is the electric current. How we define the electric current? Electric current is the flow of the charges or rate of the flow of the charges. Like how many charges will flow through a wire in 1 second, that is known as the electric current. And what is the origin of the charge? The origin of a charge is actually an atom. An atom consists of nucleus, which is having protons and neutrons, and around the nucleus the electrons are there. So when atom loses these electrons start to move, and that result in a formation, or that produces a current. So, why we don't say it's a movement of protons? The reason is that because the protons are tightly bonded in the nucleus, so it's not coming out from the nucleus until unless there's a change in the nucleus. That's why mostly what we observe is a movement of electrons. So the electric current, it is rate of flow of charges. So how many charges will move through a wire every second? We call that as electric current. The current is divided into two categories. It can be an AC, alternating current, or DC, or known as the direct current. What is the meaning of the term AC or alternating current? In AC or alternating current, the charges are actually vibrating and they transfer the electrical energy. So it's not like the charges travel from one place to another. So we have the charges, and these charges are vibrating about the fixed position and they transfer the energy from one place to another, the electrical energy. This type of a flow is known as alternating current. But in DC or a direct current, what actually happen is the actual movement of the charges actually move from one end to another. So the charges actually travel from one place to another, and the motion of the charge is not a rectilinear motion, like it's not in a straight line. The charges move through the structure, changing their direction, but the net resulting direction is there. So this flow, when the charge actually travel from one place to another, we call that as a DC or direct current. So to represent the alternating source, we use the symbol. This is a symbol. And to represent the direct current or DC, this is a symbol. In AC, like whenever we have an AC supply, so the direction of the flow of the charges changes by itself. So if this is an AC supply, so first left hand side is positive, right hand side is negative, and the flow is from positive to negative. Then we change, the terminal changes by itself, positive and negative, so the flow will change also. But in DC, it remains same throughout. If we have a DC supply, if left hand side is positive, right is negative, so the direction will be always from positive to negative. And the direction of the flow from positive to negative, we call conventional current, where the direction of the flow from negative to positive, we call that as electron flow. We can also represent these ACs and DCs in terms of the graph. In alternating current or AC, we use both axes like a positive and the negative for the y-axis. So if you just, the current is changing, so this is sinusoidal wave representing an alternating current. But if we have a DC or a direct current, the direction of the current does not change. So we use only one of the axes. Either we use a positive axis or we use a negative axis. So any one of the axes is used to represent the motion of these charges. On x-axis, we have time. If I draw a graph like this, a current and a time, and I do half waves, what is this? AC or DC? Which current is this? Is it an AC or a DC? This is actually a DC. This is not an AC, it's actually a DC. Why? How we identify it's a DC? Because we use only one of the axes. If you use both axes like positive and the negative, then it is an AC. Otherwise, if you use only one of the axes, it means it is DC. And this is a variable DC. When we use a diode in the circuits, that diode convert AC to DC. That's why diode is also known as a rectifier. Like it rectify the current. Another example, if we have a current like this, what is this? AC or DC? So this is also a DC because we use only one of the axes. If you use only one of the axes, either a positive or a negative, it will be DC. This is a pulsating DC, like a DC switch on, then off, then switch on, off. So the current is the flow of the charges. If we want to find the electric current, it is charge divided by time. And if a charge flow in a short time means it will produce a high current. If greater number of the charges are moving through a circuit, in that case, it will also produce a high current. Then related to the current, we have an equation which we call a transport equation. You have to learn the derivation of this transport equation. What is a transport equation? Transport equation actually shows a relation between the area of the wire, the length of the wire, the speed at which the charges are moving, and the number of the charges which are flowing. Example, we have a metal wire with a cross-sectional area of A. A is the cross-sectional area of this wire. The number of the charges in a unit volume, like how many charges are there in a unit volume, or we can also say a charge density, that is N, like how many charges per unit volume. V is the speed at which these charges are moving, and we derive this for a DC, direct current, we are deriving this formula. V is the speed at which the charges are moving, and L is the length which the charges will cover, the length of a conductor, that is L. If I say the current I will be equals to Q divided by T. What is a Q? Q is the total charge which will flow. So if I need the total charge which will flow, so the Q will be equals to the charge density, like number of the charges per unit volume, multiplied by the volume and multiply by the charge of one electron. Because Q is, we want the total charge. So what is the total charge in this wire? Total charge is the number of the charges in a unit volume. Like example, if I say there are two charges in a unit volume and the total volume is 10. So how many total charges will be there? So it will be 2 multiplied by 10, which is 20. So if we multiply the charge density with the total volume of the cylinder or a wire, we'll get the total number of the charges. And because these charges are electron, one electron carry a charge of 1.6 exponent minus 19 coulombs. That is a fixed value. That is the charge of one electron. So if I multiply this total value by a charge of one electron, I will get the total charge. Is it clear till this point how I get this formula till now? Q is NVA. Anyone having a doubt or a question till this point? Yeah, sure. I will explain the formula again. See, we have a cylinder which is having a cross-sectional area of A, and the total length of the cylinder is L. The number of the charges which are present in a specific volume, in a unit volume, 1 meter cube, or 1 centimeter cube, or 1 millimeter cube, that is given by N. N is called a charge density. like how many charges in a unit volume. So that is n. If I say I want to find total number of the charges, like the total, how many charges are there total in total? So what I will do, the number of the charges in a unit volume, number of the charges in a unit volume multiplied by the volume of this whole cylinder or a wire, I'll get the total number of the charges. And each charge is having a value of a q because these are electrons, which is 1.69 exponent minus 19 coulombs. That's a charge of 1. So if I need the total number of the total charge on them, so I multiply by the charge of electron, q, or you can also use the term E. So Q will be equals to the charge density times the total volume times the charge of one electron. So we got the total charge which is present in this wire. And if we simplify this equation, so Q is equals to N. What is the volume? Volume is area multiplied by length because the cylinder has an area of A and the length L divided by into Q. So the total charge which is present in the wire is given by a formula charge density times area times length times the charge of one electron. Is it clear? What is the value of a Q? Value of a Q is a charge of one electron. That is 1.6 into 10 to the power minus 19 coulombs. That is the charge of electron. Now, because the transport equation, we want to derive a formula for the current. So, current is charge divided by time. So, what is the total charge? The total charge is the charge density times area times length times q, the charge of one electron, divided by time. Like we just substitute the value for q here. What is length divided by time? Which quantity we get? Length over time, distance over time. We get the speed. So we can say that I equals to N A V Q. This equation is known as the transport equation. The transport equation actually shows a relation between the charge density, the cross-sectional area, the speed at which the charges are moving with the current. Q is a constant value. It will not change at all. Like charge of electron is fixed, which is 1.6 exponent minus 19 coulomb. So it will not change at all. Any question or doubt in this? So what we did in a transport equation, we got the value that the total charge is the number of the charges multiplied by area multiplied by length into Q. And we substituted here that number of charges, area, length, Q divided by the time. So when length divided by time, we get speed. So N is representing the charge density. A is representing the area of the wire. V is representing the speed. It is not only known as a speed, it is called a drift speed. Because the charges are not moving in a straight line, the charges drift when they move through the wire. That's called as a drift speed. And Q is the charge of one electron, which is 1.6 exponent minus 19 coulombs. So using this charge, like the transport equation, we can work out the relation between the cross-sectional area, the drift speed. So if I say we have two wires, if we have two wires, which are having different cross-sectional areas, connected to each other with the same supply in series. The area of this one is A, the area of the second one is 2A. Okay. And they are made up of same material. If they are made up of same material, so N will be same for both of them. Same material. So n will be same for them. If I want to compare the drift speed in 1 compared to 2, which one will have a higher drift speed? Or if I want a comparison, which one you think will have a higher drift speed? First one or second one? Or same? So if we compare the drift speed, look, we write the transport equation because they are connected in series. When the two components are connected in series, they will have the same current. So if I apply the transport equation for the first one, so it will be I equals to N, the number of the charge carriers in a unit volume. A is the area. V is the speed, like example I called V1, and Q is the charge of electron. If I compare the current in the second wire using a transport equation, it will also have the same current because they are connected in series. So when two are connected in series, they will have the same current. So it will be N, the charge density. And I said that these two wires are made up of same material. So they will have the same charge density. A is the area, but the second one is having area of 2A. V is the speed and Q is the charge. Because they're connected in series, so they will have the same current. So if I compare them, the two equations, so N into 2A into V2 Q is equals to N into A into V1 into Q. Q will cancel with Q, N will cancel with N, A will cancel with A. So what is the relation here? You can see like 2V2 is equals to V1. Means in V1, like the speed in V1 will be twice as V2. So when the two wires are connected in series, the one which is narrow will have a higher drift speed as compared to one which is wider. So the first one, the charges will move faster, and the second one, the charges will move slower. Is it clear? This one, the transport equation. Any doubt in this? Okay. Okay. Now, the materials can be divided into categories depending on their nature to conduct electricity. So, materials can be conductors, semiconductors, or insulators. This is in terms of electrical conductivity. If we compare, we can also compare the material in the presence of N, like the value of N, means the charge density. So which one you think will have a higher charge density, like more free charges in a unit volume? That's good. Conductor, we expect to have a very high charge density. Insulator, semiconductors, we expect that they will have a low value of a N. And what about insulator? Insulator will have zero charge density. Like it's about the number of the free charges, not about the overall charge. It's about the number of the free charges. So in insulator, there are no free charges. And what is the reason for that, for not having charges or different number of charges? Is the type, is the structure of a material that affects, that decide how many charge per unit volume. Like in a conductor, all metals are conductors. Rate of conduction is different in different metals. The structure of a metal is what explains why the metals are good conductor or why the metals have a high value of a charge density. So because metal, the structure of a metal, it's a lattice of the positive ion and the delocalized electrons. So these electrons are free to move within the structure. So if I take a specific volume of the metal, like if I take a certain volume of the metal, I will find that in this volume, I will find more free charges. What about the semiconductors? Semiconductors are, there are some like natural semiconductors are there, which we call intrinsic semiconductors. And we do additional thing we call doping so that we make them more conductors. So group 4 elements such as silicon, germanium are the semiconductors. What kind of structure they have? They have a giant covalent structures. Like in chemistry, you have studied different types of structures, simple molecular, giant lattice, so and giant covalent. So this silicon is having a giant covalent structure. So what happened out of 1 million? This does not happen for all the atoms. If you have 1 million atoms, out of 1 million, one of the electron in the bonding, because of the energy from outside, it jumps out, it moves out. So as a result, what will happen? It leave a vacancy, like the bond is not broken here, but out of 1 million, one electron is coming out from the structure and start to move within the structure. When this electron is removed out from the structure, we call that as a hole. So out of 1 million, it produces one electron and hole. So if we have 2 millions, there will be two electrons and two holes. What is the advantage of these holes? Like holes are actually spaces where the electrons can jump from one point to another. So in a semiconductor which is having a giant structure, so out of 1 million, one electron jumps out from the bonding and it start to move within the structure. So when it start to move within the structure, the material start to conduct electricity. But the conduction will be very low. Like if I take a 1 unit area or 1 meter square or 1 centimeter square area, I will get only few charges. That's why we say the value of the N is very low. Is it clear? This concept of the semiconductor and why low conduction? Anyone having a doubt or a question in this? Why did the electron jump is because these electrons are absorbing energy from the surrounding. It can be a light or a heat. So when they are absorbing energy or exposed to the light or a heat, the electron get excited and they break the bond and move out from the bonding. That is what happened. So due to the external changing factors, that is why if you remember in IGCSE, like example LDR, light dependent resistor, what was happening to a light dependent resistor or LDR, which are also a semiconductor, when there is more light, when we have more light, what will happen to the resistance of the LDR? The resistance of LDR decreases. Why the resistance of LDR decrease? Because when we have more lights, more electrons are coming out from the structure. So it start to conduct electricity at a higher rate or the current increase. So we say the resistance will decrease. Same thing for a thermistor as well. Thermistor is also a semiconductor. So its resistance changes with the temperature. So when more heat is there in the surrounding or a high temperature or hot conditions, so what will happen to resistance of thermistor decreases. Why the resistance of thermistor decrease? Because more electrons which are involved in the bonding are coming out from the structure. So due to heat or a light, the semiconductor resistance changes. Is it clear? The concept of a semiconductor and the value of N? But in insulator, we don't, they have a molecular complex structures, most of the insulators. So they are bonding, but these bonds does not lose any electron when the energy is provided. Like example, even we say glass is an insulator, but even glass can conduct electricity, but it is at a very high temperature. Like if glass is insulated at room temperature, but as we increase the temperature too much, then we start to produce those electrons or break the bond and the material start to conduct. But at room temperature, insulators, like it does not have free charges. So the value of N is equals to 0. So this is the explanation of N. The N is not constant for the semiconductor. For a semiconductor, the value of N changes with the temperature and light. If more light or a high temperature, the value of N will be higher. If we have low light intensity, then the value of N will be lower. Water is water is a conductor. Water is not a good conductor. Water is a poor conductor. It can conduct electricity, but at a very low rate. If we have a salt solution, a salt dissolve, If we have a salt solution, salt dissolve in water because of salt break down into ions, and these ions start to move, which increases the rate of conduction. So this is the explanation of the material in terms of N. So for semiconductor, the value of N is very high. For conductor, the value of N is very high, like infinity, you can say. It has a finite number, but just in a comparison, for semiconductors, the value of N is very low and it changes with temperature and light. And for insulator, the value of N is approximately zero, as the heat and the light cannot break down the bonds. This is the theory which explain the value of N. There's also another theory which explains the material, and we call that as a band theory. It's just a theory. It's when we say it's a theory, why would N increase in case of a why would N increase it in case of losing? Look, what is N here? N is the number of the charges in a unit volume. So when more electrons are there, so more electrons in a unit volume will appear. The N is not like number of charges, N is a number of free charges in a unit volume. So in a unit volume, how many free charges are there? That is N. So in a semiconductor, as we increase the temperature or we increase the light intensity, so more electrons are there in a unit volume. So the value of N start to increase. In detail, we'll discuss about semiconductors in like how we can make diode and working of a diode. In detail, we'll discuss. Now it's a band theory which explain the band theory, which is explaining the material, why some materials are conductor. When it is a theory, it means practical evidence is not there. This is just a theory. Theoretical explanation is there about this. That why materials are conductor, semiconductors, and insulators. So why we say material are conductors? So there are two bands are there. One is called a conduction band. Another one is called a valence band. So in the conductors, the valence band and the conduction band are actually overlapping with each other. This is a conduction valence band. I'm writing VB and the conduction band. What is the meaning of a term valence band or a conduction band? Like when electron is in a valence band, it can vibrate, but it will not move from one place to another. But when the electron is in a conduction band, it can vibrate and it can move from one place to another. So in a conductors, the charges, most of the charges are in a conduction band, like they're in a state to move, and very few of them in a valence band. And they continuously move from valence band to conduction band. Like in a metal, we have a lattice of a positive ion and the delocalized electrons. So what happened that these electron, like example, say this is an electron. So this electron move, when it is moving, it is a conduction band. Then it stop. It will be valence band. Then again it start to move conduction band. Then it stop, valence band. Then it start to move conduction band. Then it stop, valence band. So electron start and stop continuously within the structure. So the electrons are actually, the charges are actually jumping from valence band to conduction band. Sometimes they move, then stop, move, then stop. And this happen continuously. That's why in the conductors, because the conduction band and the valence band are overlapping with each other, that's why it conduct electricity at a higher rate. But in a semiconductors, there is a gap between the valence band and the conduction band. And charges need some of the energy to jump from the valence band to the conduction band. So this is a valence band and here CB is the conduction band. So charges need some energy as the conduction band and the valence band are not overlapping with each other. So they absorb this energy, and from where they absorb this energy? They absorb this energy in the form of heat and light. So when the charges absorb energy in the form of heat and light, they start to move, like they jump to a conduction band. Once they jump into a conduction band, it will start to move and move from one place to another. Most of the carriers are in a valence band and very few of them are in a conduction band. This is a semiconductor. But in insulator, what happened? That there is a large gap, like infinite energy is needed to move the charges from the conduction valence band to the conduction band. So enormous amount of energy is needed to move these charges. That's why in the insulators, the charges remain in the valence band and they are not in a conduction band at all, because this gap might be infinity. Like too much energy is needed to move these charges from the valence band to the conduction band. So this is a band theory which explain. So like example, we have silicon which is bonded with another silicon. So right now all of them are bonded. So all of them are bonded. It means they are in the valence band. But what happened? One of this absorb energy from the surrounding heat or light, and this start to move out. So when start to move out, now this one start to move out. So it is in a conduction band. When they are not moving, valence band, only vibrating, but when they start to move within the structure, we call conduction band. So in the semiconductor, the charges absorb energy, they need some energy to move into the conduction band. An insulator, infinite energy is needed to move the charges from valence to the conduction, so it's not able to conduct electricity at all. Is it clear, the concept of a band theory? Anyone having a doubt or a question in this? Then just the last thing, we have the electrical circuits, because we are doing a current. Bands are within electron shell. This is, yeah, actually bands are within electron shell. That's right. It's the energy of electron which decide the band. It's just a theory. It's not like showing the same like a shell. It is just a theory that explain that when electron get this much energy, it will be in a conduction band. When electron is having a certain range of energy, it will be in a valence band. So this is actually classifying the electron in terms of the energy. So there is no place actually, like we don't have shells, which we say it's a valence or a conduction, is the energy of electron, which we say, if which have like say more than 100 joules, we say it is in a conduction band. If it is less than 100, we'll say it is in a valence band. So we have current in the circuits, electrical current in the circuits. So we have series and parallel. In series circuit, when two or more components are connected, there's only one way for the charges to move. So if we have two lamps, one connected to next to other, so this is a series circuit. And if we have two or more lamps which are connected in parallel, one like separate connection for the two or more components, that's a parallel. In series circuit, the current is same at all the points. So if like 2 ampere current enters, same 2 ampere will flow through lamp 1 and same 2 ampere will flow through lamp 2. But in parallel, the current will divide. If 2 ampere is there, it might divide evenly or uneven depending on the resistance of the component. So 0.5 here and 1.5 ampere. So which lamp is having a high resistance, lamp 1 or lamp 2? Which lamp is having a high resistance, lamp 1 or lamp 2? So lamp 2 is having a high resistance because lamp 2, small amount of the charges are able to flow. Like out of 2 ampere, 0.5 are able to flow here and majority of the charges are moving through the lamp 1 because the current always flow through a least resistive path, the path which is having a less resistance. That's why most of the charges will flow through lamp 2 and few of the charges will flow through lamp 1. But in this case, the total current will be same throughout the circuit and at any point. And related to this, there's a law which is known as the Kirchhoff's law of electrical circuits that we will do tomorrow, the next session. So this is about the today I just give introduction to electrical circuits and the transport equation as well as the concept of the charge density and how we can compare the materials on the basis of the charge density according to the band theory. Any question or a doubt you have related to the session today? Any question or a doubt? Okay, so I'll end the session now and share the related recording.